Greetings. Today's lecture is on the average rate of change of a function. So before we understand the instantaneous rate of change, or how functions change at an instant in time, we have to understand first how functions change over an interval or a period of time. So this is called the average rate of change. And we'll say of some given function, so of a function, should call f of x, and then over a specified interval. So we have to specify the interval, so from x is equal to a to x is equal to b. And the definition of the average rate of change, so I'll just call it AROC, it's given by f of b minus f of a divided by b minus a. So let's understand what this definition means graphically first. So let's draw a graph. So there's x, there's the y-axis, and so we'll just draw a graph of a generic function f of x, something like this. And suppose we want to understand the average rate of change between 2 points, for example, this point and this point over here. So this would be the point x is equal to a, and then this is the point x is equal to b. So to understand the definition, which is f of b minus f of a divided by b minus a, we have to understand what these different terms look like graphically. So f of b is going to be the height of the function at the point x is equal to b. So x equals b is down here, and the height will be the y value associated with this point right up here. So we'll call that f of b. Then similarly, f of a is just the height at x is equal to a. So f of a is going to be the height right here, like that. Now the difference, f of b minus f of a, is just the distance between this point and this point. So it's literally the vertical change. So if I draw a little line segment in here, that has length f of b minus f of a, squeezing that in. Likewise, b minus a is just the horizontal distance. So it's the distance between x is equal to b and x is equal to a. So this distance right here is just going to be b minus a. Extend this vertical line out. So we see that this distance is f of b minus f of a, and the distance down here is b minus a. Now when you divide the total change in height by the total change in width, you get a slope. So this is something that represents the slope, but a slope of what? Because our function isn't a line, it's just some random curve. It could be doing any number of things between the 2 points. But if we connect the 2 endpoints with a straight line like that, the slope of that line, so let me draw it like this, so the slope of this line is just going to equal f of b minus f of a. So that's the delta y, so it's the total change in the y value, divided by b minus a, which is the total change in the x value. And so that you can understand the average rate of change of a function graphically by just understanding that it represents the slope of the line that connects 2 endpoints if the function were just a single line instead of some sort of wavy curve.